Okay, so the beginning of chapter 5 is also going to be on test 3. It starts with systems of equations. Now, systems of equations are linear equations extended to multiple variables. Ax plus by equals c is a linear equation, and if you have multiples of these, it creates constraints on variables, which creates a system of potential equations. There are 3 solutions: graphing, substitution, and elimination. We are not going to focus on graphing. Generally speaking, graphing, if it's 2 lines, it will either cross like this at a single point, so a single solution, or the 2 lines could be parallel. There's no solution, or technically they could be on top of each other, in which case there are infinite solutions, but don't confuse infinite with every point is a solution, because obviously the point, say, over here is not on the graph. So whatever x is or y is, the other one will have to adjust to make sure it's on the graph. Okay, so let's start with substitution. I'm not going to focus too much on the 2x2s. Solve one equation for any variable. Substitute what that variable is equal to into the other equation. So the easiest variable to get by itself, looking at here, is probably this y, by adding x to the other side, and taking this x plus 3 and putting it in for y in the first equation. 3x plus 2 times x plus 3 is 11. From here we solve for x. Once we have x, we can plug back in for y. Don't forget to distribute. 3x plus 2x plus 6 equals 11. That's 5x, subtract the 6 over, equals 5. So x is 1. So again, this is an ordered pair. It's a coordinate point in the 2-dimensional plane, so I need the y that goes with it. We already have a function solved for y, so y equals 1 plus 3, which is 4. So we have the point 1, 4 is a solution of the system of equations. This is how you do it with substitution. It's not my preferred method, but there will be some on the test where I say you have to use substitution. Let's talk about elimination. So for elimination, you try to line up your variables so that when you add the 2 equations together, one of your variables cancels. If you think about what things add together to cancel out, like 5 and -5, 3 and -3, -7 and +7, you need opposite additive inverses as coefficients in front of one set of variables. This means sometimes you will have to multiply one or both equations to get there. Your other goal is to make sure all of your x's and y's are on the left side. Now if we start with a basic one, number 1, we already notice that 3 and -3 are already in front of each other, so that when I add them together, 3x plus -3x cancels. 2y plus y is 3y. 11 plus 4 is 15. So I solve for y now. We get y equals 5. Again, this is a coordinate point, so if I have a y, I need the x. I will take the y, plug it back in. 3x plus 2 times 5 equals 11. 3x plus 10 equals 11, which means 3x is 1. So x is 1/3. Means I have the point 1/3, 5. Just like before. So let's see what happens when you potentially have to multiply in order to get things to line up. Sometimes you'll have to multiply one equation, sometimes both. So let's look at number 3. 3x minus 4y equals 1, 2x plus 3y equals 12. Now these numbers don't line up. I either need the x's to line up or the y's. To do that, there's no nice way to turn a 2 into a -3. There's no nice way to turn a 3 into a 4. So I'm going to usually have to multiply both equations unless one of the coefficients goes into the other. Now I know that 4 and 3 both go into 12. So if I multiply this first equation by 3 and the second equation by 4, I can get 9x minus 12y equals 3. Here I get 8x plus 12y equals 48. So that when I add them together, the y's will cancel. So we get 17x, y's cancel, equals 51. So that when I divide by 17, I get x equals 3. And again, I still have to plug that back in. 2 times 3 plus 3y equals 12. I could use any equation. I usually choose the one with the addition when given the option. So 6 plus 3y equals 12. 3y equals 6. So y is 2. Which means my solution is 3, 2. Now, all of these three problems that we've done so far have had singular solutions. The question becomes, what's going to happen, or how do we identify when we have not three solutions? We have either no solutions or infinite solutions. So we'll look at the next page. Inconsistent systems are when you have no solutions. In both of the situations where we have no solution or infinite solutions, when we're canceling out one variable, the other one will cancel out as well. So inconsistent systems are when you get 0 equals some other number. Infinite solutions are when you have 0 equals 0. So let's look at number 1. I'm going to do this by elimination because it looks easier to do this by elimination. So I am going to multiply the first equation by 2 to get 6x minus 4y equals 8. When I add these two together, I get no x's, but also the y ends up canceling. So I have nothing on the left side equals 15. You ask yourself, when is 0 equal to 15? Never. So that means we have no solution. Because 0 is never equal to 15. But let's look at number 3, and we'll do this one by substitution. I get y equals 4x plus 2. When I substitute it in, I get 8x minus 2 times 4x plus 2 equals negative 4. It's 8x minus 4 equals negative 4. The x's cancel, and we end up with negative 4 equals negative 4, or 0 equals 0. Now, when is that true? This is always true. Now again, this doesn't mean that any x and y is on the line. It just means I have to be somewhere on this line. I need to be somewhere on the line y equals 4x plus 2, which means normally when I have a line like that, we let x be whatever it wants. So instead x can be whatever x wants, but the y has to adjust to be on this line. It's got to be equal to 4x plus 2. So this would be my solution with x being what we call the free variable. It can do whatever it wants. But this can also be solved for y. I just need to get an x solved equation, x equals something else. So we have, to get x by itself, I can move the 2 over, y minus 2 equals 4x, and divide by 4. That would be x equals 1/4 y minus 1/2. So if I let y be the free variable, x would have to adjust to y. It would have to be 1/4 of whatever y is, minus 1/2. And either one of these could possibly be solutions. Now, on your homework, it may tell you to let x be the free variable or let y be the free variable, so you need to be prepared to solve these for either situation. And in the next video, we'll deal with systems of 3 equations in 3 variables.